What I'd like to do is show you an example of an unusual material called ferrofluid. Ferrofluid is an oil that is loaded with many little tiny magnetic particles. The magnetic particles are coated with a special surfactant around about them to stop them all clumping together into a single magnet, and so they act as a liquid that has magnetic properties. So if we bring a magnet close to the ferrofluid, we find that you can move the black ferrofluid around by moving the magnet around. So if we apply a strong magnetic field to the ferrofluid, something quite unusual happens, in that the single black blob of fluid splits up into an array of little black blobs, all spike-shaped, that are pointing away from the magnet. What's happening here is actually quite a complicated balance of different forces acting on the system. To start with, we have the magnetic force, which is trying to cause the ferrofluid to stretch into long filaments following the magnetic field lines from the magnet. At the same time, surface tension on the droplet is trying to pull it into little balls, into little droplets. And so the particular shape that you get from the ferrofluid, the array of droplets, is a combination of these forces that find some balance which minimizes the total energy of the system. So what are ferrofluids useful for? Well, one of their major applications at the moment is in the hard disk drive in your computer, which uses a small droplet of ferrofluid around the spindle that spins the disk extremely quickly. This is used in order to hermetically seal the disk drive in order to stop getting dust onto the fantastically clean surface of the drive. In the future, these fluids where you can manipulate a liquid droplet and change its shape could be useful in making deformable, controllable mirrors in a field called adaptive optics.